Good morning, welcome back to Math Expressions with Miss Hasty. Today we are at lesson 6-6, Model and Solve Comparison Problems. I'm going to be drawing the models for you today so that you have them to refer back to in the future, okay? So you need to be in your activity book on page 255. Today we're going to be working through 255 and 256, and then we'll go on to homework and remembering, okay? Let's start out on page 255, and they have a model for us showing spelling compared to math, and we're going to write some comparison sentences comparing the two and then some comparison equations. All right, let's read the directions here. The model below represents the time a student worked on spelling S and math M homework. Use the model for problems 1 through 3. So we have spelling and we have math. Now you can see by these comparison bars that math is much bigger than spelling. And that's typically the way our day is, isn't it? So number 1, write a comparison sentence that includes the words as long as and compares. Okay, so if we were going to compare M to S using those words, M, all right, get the drawing on here again. M is 7 times as long as S. Sorry, that doesn't write the prettiest. Okay, that would be a comparison sentence of M to S. Now S to M, S is 1/7 times as long as M. So when we're comparing 7 times as long, a whole number, that's expanding it. When we're taking it times a fraction, then we have a smaller answer. And we'll see that in the problems that are coming up. So now we're going to write a comparison equation that compares. So if we look at this, M equals 7 times S, okay? And likewise, comparing S to M, S equals 1/7 times M. So those are comparison equations and comparison sentences. Now, if we were to write a division equation that compares S to M, think about that for a moment. What do you think that would look like? Okay, so S is on one side, M is on the other, and we needed a division equation. Okay, so if we were going to do that, S equals M divided by 7. Okay, and if you just look back, S equals M divided by 7. And that would be a division equation that compares the two. Okay, let's do some problems that show this. Number 4, the length of an unstretched spring is 120 centimeters. How long will the spring be if it is stretched to 3 times that length? Well, if we used a little bit of a comparison bar here, the unstretched is 120. And if we stretch it 3 times that, okay, so 120 times 3 is going to give us how long the spring will be if it's stretched 3 times that length. Okay. Number 5, the length of a collapsed length fishing pole is C, which is, okay, the C is 1/8 times as long as the extended length. So we're taking a fraction of the extended length. The extended length of the pole is 16 feet. What is the collapsed length? Okay, so this is C, right? And we know that the full pole is 16. Right? So it's telling us that the collapsed pole is 1/8 times the fully extended pole. So what is the length? And of course your label is going to be in feet. You're taking 1/8 times 16. Okay, let's go on to page 2, do some more word problems here. Multiplication and scaling. You can predict how resizing one factor will affect a product. So let's solve these together. Number 6, Gina and Mario each received a weekly allowance. So far this year, Gina has saved $20 and Mario has saved 0.4 times that amount, or 4/10 that amount. Now remember, when we're taking a whole number times a decimal or a fraction, you're going to end up with a smaller number, okay? Who saved the greater amount? Okay, so Gina has saved 20 and Mario has, let's read this again, 0.4 times. So 0.4 times 20. Now I would expect your prediction is, because you're taking a decimal times a whole number, Mario is going to be your prediction, okay? And once you solve that problem, you'll see that Mario saved less, okay? Number 7, last week, Camelia worked 40 hours. Sergio worked 4/5 that length of time. Again, here's a whole number, here's a fraction. We're taking a portion of that. So we know which person worked more hours last week. Well, Camelia worked more, and then I want you to solve that problem. So it's 40 times 4/5 to get Sergio's hours that he worked, okay? Number 8, on a math quiz, Juan was asked to find these two products, 3 times 10.6 or 2.7 times 10.6. Without using a pencil or paper to actually find the products, how will the product of 3 times 10.6 compare to the product of 2.7 times 10.6? Okay, think about that for a minute. Look at your two numbers. 10.6 is the same for both, but these two are different. So hopefully you would see that 3 is greater than 2.7, so the product of 3 times 10.6 will be greater than the product of 2.7 times 10.6, okay? And vice versa, how will the product of 2.7 times 10.6 compare to the product of 3 times 10.6? Okay, that you should see that 2.7 times 10.6, it's being glitchy on me, will be less than the 3 times 10.6 because 2.7 is less than 3. All right, number 9 on our activity pages. How does the value of a fraction change when both the numerator and the denominator of the fraction are multiplied by the same number? Think about that for a minute. If our numerator and denominator of the fraction are multiplied by the same number. So let's do an example. Let's say 2/3, and I'm going to multiply both of those by the same number. 3/3, okay? How will the value of the fraction change? It won't change, will it? Because what do we know? This 3/3 is equal to 1, okay? So it will be the same. It will stay the same. And hopefully that's something that you recognize. Okay, that concludes our activity pages. Let's go ahead and look at 6-6 homework side and remembering. Let's read through our story problems for 6-6 homework. And we'll draw a model if helpful, okay? Number 1, a flagpole flying the Ohio State flag is 9/10 the height of a 30-foot tall flagpole that is flying the U.S. flag. What is the height in feet of the flagpole flying the Ohio State flag? So it is 9/10 the height of the 30-foot tall flagpole. So we're taking a fraction times a whole number. And our answer, oopsie, let's go ahead and get our pen going again here. Little persnickety, 9/10 of or times the 30-foot tall. Make sure you put your whole number over 1. Simplify first if you can. Multiply it out to get the flagpole height of the Ohio State flag. And the measurement is in feet. Number 2, the number of students in period 7 study hall at Jin's school is 4 times the number of students in Jin's homeroom. How many students are in the study hall if there are 16 students in Jin's homeroom? Okay, so here we have, there are 4 times the number, so 16 students in the homeroom times 4 is going to give you how many are in the study hall. Again, your label is how many students, okay? Number 3, the enrollment at Roosevelt High School is 1,045 students, which is, so that 1,045 is 5 times the enrollment of Truman Middle School. How many students are enrolled at Truman Middle School? So Truman Middle School times 5 is the 1,045 at Roosevelt High School. So to solve for the unknown factor, we need to take our product, divide it by the factor we do know to give us our unknown, and our label is students. Okay. Number 4, a truck weighs 5,400 pounds. An open wheel race car weighs 1/4 as much. Again, we're taking a decimal and we have a whole number. How much does the race car weigh? So we're going to do 1/4 of, or times, the 5,400. Okay, numerator times numerator, denominator times denominator, and then you're going to have to divide it out to find out how much the race car weighs. Number 5, Owen and Maya each studied for a test. Owen studied for 90 minutes, Maya studied for 0.5 times, or 5/10 times that length of time. Who studied more? Well, we're taking a decimal times a whole number. So hopefully you recognize that Owen would have studied more because Maya is a portion of how much Owen studied. And then you're going to take the 0.5 times 90 to find out how much time Maya spent. And our label is minutes. Number 6, Sonia's family has 2 children, which is 2/3 the number of children in Zeke's family. What family has more children? Okay, so it's 2/3 of Zeke's. Zeke is going to have more children, okay? And then which family has more? Divide to check your prediction. So what do we know? We know that 2/3 of something, so times something, equals 2. How do we solve for that? You take your 2 divided by 2/3. Again, whole number over 1, and find the reciprocal of the second fraction, turn it into multiplication to solve. Okay, let's go ahead and look at our 6/6 remembering. All right, 1 through 6 is copy each exercise, then add or subtract. The reason we need to do that is because we need to set them up one above the other. Okay, so number 1, 22.09 minus 17. 17 is a whole number, so we have to remember the decimal goes after the whole numbers. So now I can set it up with the same amount of digits. 22.09 minus 17.00. Now I can do my math. Remember, we add zeros where there are missing numbers. Make sure you do the same on each one of those problems. If it's a whole number, the decimal goes after. Now, aside from adding and subtracting decimals, for 7 through 12, you're multiplying decimals. That's a little different. Okay, for multiplying decimals, we don't need to line up the decimals. But what we do need is count the digits after the decimals in both factors. If they're in both factors, count the digits after the decimals and then add the decimal into your product with the same amount of digits after the decimal. Okay, so let's do one for example. 0.5 times 0.04. Okay, I don't need to line the decimals up. I just need to do my math. So 5 times 4. All right, 4 times 0 and then 2. Okay, now I am moving over to the second one. So I need to add a 0, 0, 0. And then my third digit there, add 2 zeros. Okay. Now what I do is I go back and I say there are 2 digits after this decimal and 1 digit after that one. So there are 3 digits So I need to make sure I have 3 digits after the decimal in my product. Okay, little review for multiplying decimals. Okay, number 13. A soccer team has 35 soccer balls. 1/5 of the balls are made of leather. How many of the balls are made of leather? So 1/5 of, or times, the 35 soccer balls is going to give you how many are made of leather. Simplify, multiply, get your answer. How many are made of leather? And we're dealing in balls. 14. There are 56 fifth graders who play basketball. That's referring to the 56, 7 times the number of students who play tennis. How many fifth graders play tennis? Well, it's telling us that T is tennis, 7 times the amount that play tennis, 56 play basketball. So you're solving for T. We take our 56 divided by 7, and that's going to give you how many fifth graders play tennis. Okay? And the stretch your thinking. This is a little bit of a stretch your thinking, but I think you can do it with the background that you have. Samantha draws a hopscotch diagram on the sidewalk in front of her house. This is something you can do while you're at home. The diagram is 10 feet long. Her neighbor asked her to draw a 4-foot hopscotch diagram on a canvas mat. In simplest form, what fraction of the length of Samantha's diagram is her neighbor's diagram? So comparing those two, what fraction is Samantha's to the neighbor's? And then simplest form, simplify that fraction when you get that answer. Okay? All right, that concludes 6-6. Tomorrow we'll be looking at 6-7, some more comparison problems. Hope you have a great day. See you tomorrow.